All right, AP Statistics, we are going to talk yet some more about the normal curve. I know you're really excited. So we've already talked about standardized or z-scores. That's the title of the last video that I did. So now we are just going to talk a little bit more about using the normal curve, and just we're going to tie up some loose ends about it, and we're also going to talk about percentiles. So the first thing we need to talk about, where or when might we use the normal distribution? So I've already kind of alluded to some of these in talking with you in class and in our other videos, but some data has a normal distribution naturally. And of course, we talked about that with IQ. It's normally distributed. And of course, sometimes you're going to have data that's more normal than others, and we'll get into a little bit more of those details later in different units. Okay, and sometimes we have, we can approximate many chance outcomes in probability. All right, so we use the normal distribution for that. And then, of course, we have a lot of symmetric distributions that happen to be very large, and they can be approximated using the normal distribution. And again, we're going to talk more about those types of distributions later on. Okay, so something that is really important that you need to understand, you really need to understand this idea. Not all data follows a normal distribution, so you can't just assume that it is a normal distribution because you want it to be. And in fact, many do not, the majority of data do not follow this nice symmetrical pattern. So please keep in mind that just because you want it to be normal doesn't mean it can be. You know, just like if you want your teacher to be normal, doesn't mean she can be. All right. So anyway, my point being is that you can't assume that that data is normal. That is not going to work out for you. And so for now, I'm just going to tell you if a distribution is normal, and then of course we will move on from there as far as finding conditions and all of that. We'll do that later on. I do want to remind you, I can't remember if I said this in one of the other videos, I do want to remind you that when you have your normal distribution notation with your mean and standard deviation, please remember that these are only chosen to help you specify the model. Okay, they are not actual numeric summaries of the data. So I know that we get caught up in, hey, look at that number, it means this and this and this. Well, please keep in mind that these are not actual numeric summaries, okay? They're just a model. All right. So I know everyone has heard of a percentile. In fact, I think we've already talked about percentiles in another unit. Just keep in mind that when I ask for a certain percentile, I'm always talking about the percentage of values to the left of that. So, for example, if you scored in the 92nd percentile on the SAT, that means you scored better than 92% of people. So if you're looking at it as far as graphing it on the normal curve, let's say I'm just going to revisit my, oh, why did I write a P there? Nobody knows. I am going to revisit my IQ distribution because it's easy and I remember what it is. So let's say I wanted to know the 75th percentile. What value is the 75th percentile? Well, 75% of the graph is going to be roughly here. So this would be 0.75. So in other words, at what number, what is X, what is the IQ value that marks the 75th percentile? That means I want to know at what IQ do 75% of the people have. Like at that IQ, 75% of people have lower than that. So anytime I'm talking about a percentile, it's always to the left or below. So you need to remember that. That's the key to remembering about a percentile. If I want a percentile, I'm shading to the left. It is always below. All right, what steps are we going to take when we're looking for a proportion? under the normal curve. So we've already done this a little bit with our empirical rule, but now we're opening it up because we're going to have to actually calculate some things. So when we get to a problem, these steps will make sense. We are going to state the problem as an inequality. We are going to draw a picture, and then we are going to use a table or a calculator to find the area. We can also use Staplet for now. So I'm also going to show you that. The calculator will actually come later. All right, and then you can also include your z-score. You don't have to include your z-score for these problems, but it can be helpful. And actually, if you're using a table, you will have to use your z-score because you'll have to know how to look it up on the table. All right, so what steps do I take when given a proportion and I want to find a specific value on the curve? So that, in other words, I'm not finding an area, okay? So the way these problems can be given to you, I can either give you the x and ask you for the percent, or I can give you the percent and ask you for the x value. So that's what this is indicating. So we're going to draw a picture, state our problem mathematically, and then of course we have to unstandardize it. So again, I'm going to show you how to do this in actual examples. So one of the things we need to talk about with the normal curve is this idea that it is an area model. So what limitations might there be? Well, the biggest limitation that you're going to have is that you can't find the probability that x equals something, because equality means just at that one value. And since this is an area model, one value does not take up area under the curve. See, like if I'm just looking at this one value right here, that doesn't take up area under the curve. So I can't find the area of just one value. So that indicates that we can't find the probability associated with that one value. We can only find probabilities associated with an interval when we're using a normal distribution. Keep that in mind. All right, so as I spoke with you about already, God, I'm just stumbling over my words. It's ridiculous. I'm glad I'm not a public speaker or anything. Okay, so we have already talked about the idea that in the future we're going to talk about certain conditions being met. For now, for this entire unit, I'm going to tell you when something's normal, you'll know how to proceed. As we move through to the next unit, I am going to give you some conditions that will need to be met in order to use the normal model to find your probabilities. So that is coming. That's where we're headed. So when we get done with this unit, if you think, whew, I'm done with the normal curve, you're so not. So I just need you to focus up on that. Just saying. All right, enjoy.